What are prime numbers? Pick up any prime number. 13. 13 ka square is 169. So 169 factors of 169 are 113 and 169. And then you know how to find that a given number is a prime number. Listen, very important part. Every number can be put in terms of prime numbers. But there is only one even prime number, all other numbers are odd numbers. But every second number is an even number. What are prime numbers? Most of the time, you know, people would say numbers divisible by 1 and by itself. I take this definition to be wrong, which means you have been, doing wrong definition throughout your life. Yes, you see, numbers divisible by 1 and by itself. 1 is divisible by 1 and 1 is divisible by itself, but 1 is not a prime number. So you have to understand, you do not put exceptions when you are talking about definitions. I think this definition of numbers divisible by itself and 1 actually gives the category only two forms, prime and composite, but there are actually three forms. So please, first is prime. What are prime numbers? What are prime numbers? Today onwards, numbers having only two factors. Numbers having only two factors would be defined as prime numbers. Simple, over. Nothing more, nothing less. Right? So, you know, set of prime numbers. 2 is a prime number, 3 is a prime number, 5 is a prime number, 7, 13, 17, 19, 23, 29, 31, 37, and goes on and on and on. It's an infinite set. A lot of research is going on, but it is unending. There is no regular pattern known for prime numbers. So every year after year, somebody finds the biggest prime number. You might have read, I hope you read the news. So every year after year, somebody finds the biggest prime number, and after 1 or 2 more years, somebody finds a bigger one. So it goes on and on and on, right? It's an infinite set. Now, the beauty of prime numbers is that if you have a good vision, there is only one odd even prime number, only one even prime, only one even prime number, rest are all odd. And definitely it has to be, because any other even number, if you take any other even number to be a prime number, you would be wrong, because 1 is a factor of every number. The number itself is a factor of itself, isn't it? Number is factor of itself, and since it is even, 2 would also be a factor. So definitely if there is any other prime number, it won't be, if there is any even number, it won't be a prime number, because it would have more than 2 factors. So rest of the prime numbers, they are odd. 3, 1, 11, 13, 17, 19, 23, 29, 31, 37, and goes on and on and on. The uniqueness, all are odd. Uniqueness, all are odd, other than one even prime number. Clear? Important note, square of a prime number would always have 3 factors. Think about it. Pick up any prime number. 11. 11 ka square is 121. The factors of 121 are 1, 11, 121. Pick up any prime number. 13. 13 ka square is 169. So 169. Factors of 169 are 113 and 169. So if you have a number which is a square of a prime number, it would always have 3 factors. Clear? It would always have 3 factors. Keep this thing in mind. All right? Important point about prime numbers, first is 2 is the only even prime number. Now they can give you an amazing question on this. They can obviously give you an amazing question on this part, and generally people really struggle with this part. So let's talk about it. Listen, I say 138 xy 89 or make it 79 89 is equal to a plus b. Now listen, this 138 xy 89 is a 7-digit number. It's a 7-digit number where x and y are missing places, right? But now I say a comma b are prime numbers and a is less than b. All right, so 138 xy 89 is a 7-digit number which is equal to a plus b. All right, where a and b are prime numbers and a is less than b. So my question to you is, what would be the value of 13889 plus a? What would be the value of this? Now to most of the students it comes as a bombastic question, right? And most of the engineers, they start solving, they are good in solving, they are good in equations, and they realize there are two unknown a, b and two more unknown x and y. So what kind of equation? And then this is a 7-digit number. Think about it, guys, please. Let's think about this. Listen, we simply call this question as a puzzle. If you take it as a puzzle, listen, this 7-digit number is an odd number given a sum of two numbers a and b. Now I ask you, what is even number plus an even number? Sir, it is even. Check it out. 2 plus 4 is 6, 4 plus 8 is 12, 8 plus 20 is 28. Clear, right? And secondly, what is odd plus odd? 3 plus 3 is 6, 3 plus 5 is 8. Plus 7 is 12, plus 9 is 16. Again it is even. So if the sum of numbers, two numbers, is coming out to be odd, absolutely even plus odd actually gives you odd. Kindly mark this, write this as a real important information. Real important information. So even plus even is even, we got it. Odd plus odd is even. Even plus odd is odd, which means now I can say that a plus b, so out of a and b, one is even and another is odd. I am writing it because it would be tough for you to understand it otherwise. Can you write it? Can you write it? Isn't it? Am I right? And then, I have also written that a and b are prime numbers. We know that out of a and b, one is even, one is odd, and a and b are prime numbers. Oh, come on. Which means out of a and b, one of the numbers is 2. Why? Because there is only one even prime number. So when I say that a and b, one is even, one is odd, it's okay. When I say a and b are prime numbers, so it is automatically understood. 1 out of a and b is 2, and then it says a is less than b, which obviously means a is equal to 2, which means your answer is 13889 plus 2, which is 13891. Simple. Plain, simple, crisp logic, and it definitely works. So remember, 2 is the only even prime number, and frankly telling you, many a times whenever this kind of concept comes up, definitely it would work. Definitely this concept is going to work. So it is a real important aspect, right? And then you know how to find that a given number is a prime number. So I say is 223 a prime number. Now 223, first of all, you know, it has to be prime. It has to be prime, then just check out when you divide by 6. So if I divide 223 by 6, over here I am dividing it just the way it should be divided, but if had you done divisibility rules, we could not have divided, but chalo, we have not done divisibility rules, right? So it is 18 and comes out to 42, 1. So it is leaving remainder 1. It may be prime. It may be prime, right? So now we know that number is leaving remainder 1 or 5. It may be prime, right? The second rule. So rule over here is C. Find approximate value of root of 223. All right, find approximate value of root of 223. So what is an approximate value, guys? 223 root. Anyone? Right? Come on. Dekho yaar, it's very easy. What is, you know, listen, it's very easy. What is under root of 225? It is 15. What is under root of, see, what is 14 square? 196. What is 15 square? Now listen, it's very easy. Listen, what is 14 square? It is, what is 15 square? So 14 square, sorry, 15 square 225 and 14 square is 196. Right? Can you write it once? Now you know that we have you know, two numbers, 14 square and 15 square. So I'm writing it. 223 lies between 196 and 225. So root of 223 would lie between 14 to 15. Is it okay? Very logical. We call it approximation. So if you remember squares and square roots, which I am going to do it, don't worry. We are going to do it as a chapter, right? So if you remember these squares, things would actually be practically very easy. So it is approximately 14 point something. I don't care what something. All right. I am only bothered is once I find approximate value of a number, approximate value of a square root of a number. So it is 14 point something. So please write down all the prime numbers less than 14 point something. So 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, less than, you know, 14, then 11 is there and 13 is there. So there are 6 prime numbers which are less than the approximate square root of the given number. All you need to find is 223 a multiple of 2? No, sir. Is 223 a multiple of 3? No, sir. Can 223 be divided by 2? Exactly, no, sir. Can 223 be divided by 3? No, sir. Can 223 be divided by exactly by 5? No, sir. Can 223 divided by 7 exactly? No, sir. Just check out if you divide 223 by 7, less than 21, and this comes out to be 13, remainder 6. So no, it is not completely divisible. Can 223 be divided by 11? No, sir. And similarly, can 223 be divided by 13? No, sir. So if it is not having any of these prime numbers as its factor, then 223 is a prime number. That is the best way of testing whether the given number is a prime number or not. Please write it, guys. Best way of testing. So now we are very, very sure about prime numbers. There is only one even prime number, a kind of question that can come. Why prime numbers are important? Because every number can be put in terms of prime numbers. Prime numbers have a form 6n minus 1, 6n plus 1. Now, how do you do factorization? When we were small children meaning like we were in 9th class, 10th class. So we used to get step marks. So we used to write steps, we used to draw tables, we used to draw this antenna. But now you are only going to get one single mark for one single question. So there is no point that you draw everything, है ना? You don't need to. So listen, suppose I say factorize 9600. Kindly factorize 9600. So if you start making an antenna, definitely in that case you would be able to do only one question, right? No, just be very smart now. You can write it as 96 into 100. 96 is 16 into 6 and 100 is 10 ka square. 16 is 2 ki power and 6 is 2 into 3 and 10 is 2 into 5, 2 square into 5 square. So basically it is 2 ki power C4 plus 1 5 7 and 3 ki power 1 and 5 ki power 2. Legit. We have done it without even factorizing or without even using an antenna, isn't it? We haven't even tried using an antenna and we have got it. Numbers of factors of 9600. So let me see, 9600 again 16 into 6 into 2 square into 5 square is 2 to the power 4, 2 to the power 1, 3 to the power 1, 2 to the power 2, 5 to the power 2, comes out to be 2 to the power 7 into 3 to the power 1 into 5 to the power 2. Alright, so number of factors, guys, you have the powers, number of factors, you have the powers. So add 1 to each power, 7 plus 1, 1 plus 1, 2 plus 1, 7 plus 1, 1 plus 1, 2 plus 1. It is 8 into 2 into 3, 48. So there are 48 numbers that exactly divide 9600. And I can assure you, you cannot do it directly. Right? So kindly mark, then we will do some more questions so that you know this concept of factors does not bother you after all, huh? So first of all, first question is obviously very easy. It is number of factors. So listen, parse 4 plus 1, 3 plus 1, 3 plus 1. So sir, it is 5 into 4 into 4, 80. I hope everyone can do this. Everyone can do this, right? Then he says number of even factors. Now again that concept, again the same kind of concept that we have thought about before also, right? What concept, sir? Come on, think about it. Come on, think about it. There is only one even prime number, but that is a prime number that makes all numbers even. Listen, though every number, listen, very important part, every number can be put in terms of prime numbers, but there is only one even prime number, all other numbers are odd numbers, but every second number is an even number, which means 2 has a very big contribution, isn't it? 2 is a person that makes every odd even. 2 is a factor which makes every odd even, isn't it? 2 1s are 2, 2 3s are 6, 2 5s are 10, and 2 7s are 14, and 2 9s are 18. So are you understanding? Wherever there is odd, you multiply by 2, it comes out to be even. So for sense of logic, remember even factors would actually be more than odd factors genuinely. Alright, so let's see. Sir, number of even factors. So guys, number of even factors, remember whenever you have this question, take 2 common. So you have a number 2 ki power 3, 3 ki power 3 and 5 ki power 3, and once 2 is common, every factor from here, every factor would be even. Agreed. Every factor over here would actually be even. So because 2 is a number that makes every number even, isn't it? So now 2 to the power 3 into 3 to the power 3 into 5 to the power 3, every factor that it would have would be even factor because 2 would automatically be multiplied with it. So how many factors does it have? how many factors does it have? So powers are 3, 3 and 3. So factors are 3 and 3 plus 1 and 3 plus 1. 4 into 4 into 4, 64 even factors. 64 even factors. So number of even factors 64. Right? One concept. Then number of odd factors. Odd factors you can say total minus even. Sir, total were 80, 64 were even, 16 are odd. This would work. So kindly write it once. Please write it once. Then I'll give you another picture also. Number of prime factors. Guys, please remember, whenever you have this question number of prime factors, he is asking about these. So how many numbers are there? Sir, 3. So number of prime factors, 3 prime factors. Alright? 3 prime factors. So had there been a number which is 2 की power 3 into 3 की power 3 into 5 की power 2 into 7 की power 2 into 11 की power 3, and I ask how many prime factors are there. So without doubt, building factors 2, 3, 5, 7 and 11. So I would say 5 prime factors. Alright, over here in this question 3, over here in this question 5. So can you write it, please? This is important. Alright, then number of composite factors. Now this is important, number of composite factors. When we talk about number of composite factors, guys, in that case, keep this thing in mind. It is total 80 minus prime factors. So generally students would tell me, sir, 77 as an answer, but no, minus 1, which is 76. This one is neither prime nor composite. 3 categories: prime, composite, neither prime nor composite. So remember, total are 80, 3 are prime. There is one factor which is neither prime nor composite. It has to be minus. So there are 76 composite factors of n. Mark it, this would be the most recurring question I have ever seen, because people make such a silly mistake. Clear? Good. Number of factors, multiple of. So we have a number 2 की power 4, 3 की power 3, 5 की power 3. So take 2 common, 3 common. It is 2 की power 3, 3 की power 2, 5 की power 3. So now this is 6 we have taken outside. Now any factor from here would automatically be a multiple of 6. 6 has been taken out. Right? Any factor of this number would be a multiple of 6. So number of factors, 3 plus 1, 2 plus 1, 3 plus 1, which is 4 into 3 into 4. So it has to be 48. So there would be 48 such numbers that are factors, and they are multiples of 6. Alright. Then he says number of factors multiple of 10. Kindly mark it, kindly wrote it once. Right. And then let me change the color of the pen. Multiple of 10. So we have 2 की power 4 and 3 की power 3 and 5 की power 3. Take 2 and 5 common. Your answer is your factors inside is 2 की power 3, 3 की power 3 and 5 की power 2. Now number of factors, any factor would be a multiple of 10. So how many factors? 3 plus 1, 3 plus 1 and 2 plus 1, which is 4 into 4 into 3, which again is equal to 48. Alright. A number n, which is 2 की power 4 into 3 की power 4 into suppose 5 की power 2. I may ask you number of factors that are perfect squares. Yes, this may be a very good question. Number of factors that are perfect squares. Number of factors of n, so I can write it, of n that are perfect squares, right? So how do you do this one, guys? See, remember 2 की power 4. How many perfect squares it would have? 2 की power 0, 2 की power 2, 2 की power 4. 3 perfect squares. Remember 2 की power 0 is a perfect square, yeah? 2 की power 0 is a perfect square, isn't it? Similarly, I say 3 की power 4 would be 3 की power 0, 3 की power 2 and 3 की power 4. Again 3 perfect squares. Again 3 perfect squares. And then 5 की power 2 would have how many? 5 की power 0 and 5 की power 2. So 2 perfect squares. So how many in total? Genuinely people would add. No, we are my students. After this, kindly multiply. So number of perfect squares are 3 into 3 into 2, 18 perfect squares. 18 factors that are perfect squares, and you can count them as well. We will count them. First of all, write it. Sir, why you know 2 की power 0, 3 की power 0, 5 की power 0, you have counted them again and again. I can manually count it. Don't worry. First of all, write this. So write perfect squares, multiply them. That is really important. All right. So let me manually count it for you. See this? Let me count all 18 for you. All right. So first of all, I am removing all of these, right? Because you are right. So this is singular. If you chalk 1, 2, 3, 4, 5, 6. 6 perfect squares over here, right? And then listen, 2 की power 2 into 3 की power 2, 2 की power 2 into 3 की power 4 and 2 की power 2 into 5 की power 2, 3 more, right? Then 2 की power 4 into 3 की power 2, 2 की power 4 into 3 की power 4 and 2 की power 4 into 5 की power 2. See? Right? Isn't it? So total कितना बन गया? See, listen, you can easily check. So sir, 12 तो we are able to get, है ना? 12 तो you guys are able to get, and then you know you can combine 2 and then also you can get a perfect square, isn't it, guys? Now you understand. See, yes sir, you are absolutely right. Listen, see this. 2 की power 2 into 3 की power 2 into 5 की power 2, isn't it? 2 की power 2 into 3 की power 4 into 5 की power 2. So I say 2 more. Isn't it? See, 2 की power 2 into 3 की power 2 into 5 की power 2, 2 की power 2 into 3 की power 4 into 5 की power 2. Similarly, 2 की power 2 into 3 की power 2 into this and this into this into this. So see, 2 more. Right? So conceptually, then listen, what about 3 की power 2 into 5 की power 2 and 3 की power 4 into 5 की power 2? 2 more. So I think you are getting 18, right? Yes, sir, we are getting 18 factors that are perfect squares. So the best part was I had written 2 की power 0, 2 की power 2 and 2 की power 4. How many are these? 3 are these. Then I've written 3 की power 0, 3 की power 2, 3 की power 4. How many are these? 3 are these. And then 5 की power 0 and 5 की power 2. How many are these? These are 2. And I multiplied, I said 18. Isn't this a better thing to say? Better logic to understand? Right?